All right, hello everybody. This is Aaron from ACM Cyber at UC San Diego. This is a walkthrough of the educational challenge A Bowl of Pythons for San Diego CTF 2022. The challenge is originally from SDCTF 2021, but these educational challenges are designed for you to just follow along with me, have fun, and get familiar with the tools and techniques of each category. These educational challenges are not worth points, so if you're in the quote unquote big leagues, you don't need to waste your time with solving all of them. But for the beginner teams that do complete all of our educational challenges, you will receive a very small but very special prize to commemorate your learning, and maybe you'll have fun along the way. So with that said, I'm going to go ahead and jump right into it. Feel free to also click the link to get to the 2021 repo that is linked in the prompt of this challenge, along with a link to this YouTube video. This prompt or this GitHub repo contains all the challenges from last year and their source code, as well as a lot of information about each challenge, like number of solves, yada, yada, yada. You also see the original prompt, which is important to us, but it's not that useful in this case. A bowl of spaghetti is nice. What about a bowl of pythons? That doesn't really mean anything to me. But we do get this attachment, challenge.py, and we also get these other attachments that are, well, actually, I guess other files that were used to create this challenge, but really the only one that we should use to solve this challenge is child.py. If the other ones are helpful, then go for it, but we're just going to go with just child.py, and since that's the way that the original challenge takers in 2021 would actually, that's what they would have to solve it with. We also get more information than those aforementioned 2021 challenge takers would have gotten. For example, we also get the original specification, as well as a quite significant number of write-ups from last year, from challenges last year. Thank you, everybody who submitted a write-up from last year. But so if this walkthrough is not up your alley and you want to cut to the chase, maybe you can read one of these write-ups and get something out of it if my explanation isn't doing it for you. We also see the original flag from last year, and when I solve this challenge, I'm going to end up getting that flag, but you are going to solve this challenge and get a different flag. So just keep that in mind when you go solve this challenge, that you're probably going to get a different flag, which is why you'll have to follow along with me rather than just copy this and submit it. Don't just submit this flag. The flag for this year is a little bit different. Okay, so with all that said, let's go ahead and jump right into it. Where is my... oh yeah, so we're downloading child.py, which I have already downloaded here. Here it is. As you can see, it's a Python file that does something. It looks like, well, the part of it that I can make out easily is it says, welcome to SDCTF's first reverse engineering challenge, and it asks you to input the flag, and then it does some checks, and it's kind of hard to read beyond that. Now, this is a good example of identifier obfuscation, meaning that the different functions and variables have been masked so as to make it difficult for me to read it. But we can kind of undo this, and we'll see that this is not even that difficult to do by hand. So I'm just going to jump in and do this by hand now. Starting, I'm going to go kind of like from the top to bottom in this file and kind of try to interpret it as I go to get a better grasp of what's going on. We can see here that this first line is probably just a red herring, since it doesn't match the flag that is on the prompt, or I guess in the GitHub repo. So this is probably just here to throw challenge takers off. I think I do recall I had lots of people complaining that submitting this wasn't working last year. It's not the flag, it's just there as a distraction. You'll have to actually reverse engineer this file in order to figure out what the flag is. So this first function takes in a number n and spits out another number that is the sum of the previous two numbers, with when n is equal to 1, we get 0, I think, or if it's less than 2, we get 0. Otherwise, it's 1. So anyway, the point of this is I'm pretty sure it's the Fibonacci sequence. And you don't have to know a lot about the mathematical properties of the Fibonacci sequence other than you give it a number n, and it spits out another number, right? And even if you didn't identify this as the Fibonacci sequence, you know that it, takes in a number and spits out some other number, and you don't really have to worry about this because you can just kind of treat this as a black box and that'll work just fine. But since I know it's the Fibonacci sequence, I'm going to rename all the times it's called to fib, just so I can remember the progress that I've made here and the insight that I've made by discovering that this is the Fibonacci generator. This next function appears to take in an x. It looks like this is a string. X is a string. Converts it from hex into a byte string. So what that means is that all of these places where I call this function b and I'm passing in hex, that converts the hex into its original string format. So there's a really, first of all, let's go ahead and just rename this to something else. Like, for example, let's copy all the places and call this from hex, like so. And I'll rename it here too to be consistent. But since this is basically a form of string obfuscation on all the different strings in the program, I want to just kind of pause and undo all of that right now, if I can. And probably the easiest way to do that is to just use Python, right? Because, we're already in Python. You can pretty easily open up, if you have Python installed, a Python REPL just by running Python. And then you can, for example, copy both of these functions. Maybe we'll be using them at some point. Let's paste anyways. So now we have both of those functions defined in our REPL environment. And now we could do things like just paste that string. Oh, it's print. That's what that string means. Okay, great. And then I can just replace this with, print. And I can do that for all of these strings, which I will now do. I'll try to go a little faster. Looks like this is the string that you get when you incorrectly guess the flag. It looks like this string is evaluated, which may be important. Oh, it looks like it's just a call to exit 1, but I'll just replace the string for now. This string looks like it is the string you receive when you do guess the correct flag. So that's our victory condition. That's good to be able to identify. And this string, lastly, is just another call to exit, although with a different code. Okay. Great. So we've undone all of the hex stuff. Honestly, with that gone, we can just kind of remove this function. It's easier now. We see that we have a couple places where we're calling eval, right? Eval just takes the string that's inputted and runs it as Python. So anywhere where we see this, we could just replace it with the code that it's calling. So for example, this is actually just a call to exit 1. This is just a call to exit 0. And this is just the function print. So whenever we're calling the function h, we're actually just calling the function print, which of course outputs that string. So let's go ahead and replace it in all those places, and we could just get rid of this. Simplifies the file a little bit. Okay, well, we're in a lot better place. Continuing our journey downward, we see this function d. All it does at this point is print the string incorrect flag and then exits. And then I think this code is unreachable, but it's again just the red herring flag from before. Because this is the function that just seems to kill the execution and tell you failed, I'm going to go ahead and call this the fail function. And then I know whenever it's called, that means we failed some condition. And this will be a lot more readable down here. Now we kind of get the impression that essentially what the rest of this function does is it has you input a guess, which actually that might be a good idea if I just replace all of these with the word guess, as well as this one before I forget. It takes in a guess, and then it does these 3 checks. And if it fails any 3 of these checks, then you clearly didn't guess the right flag, it exits. But if you pass these 3 checks, we know that it tells me it's the correct flag. So we can probably assume that this function, which now that I look at it is called on this big scrambled byte string as its input f, is going to probably only pass these 3 checks if the guess matches the flag. So let's decode each of these checks in turn. The first check is interesting. We're only grabbing the first 6 characters of the guess. We're encoding it to hex, and we're comparing it to this, which, now that I'm looking at it, appears to be a string that is using Python's format string features to kind of insert these numbers into this string in the places that are kind of highlighted in the dark green here and surrounded by curly braces. So for example, it's kind of similar to printf in C, but if you've ever used format strings in Python, basically everywhere where I've input 0 here, or surrounded by curly braces, it's going to replace that with the 0th item in this array, which in this case is just a 6. And all the places that are just curly braces surrounding a 2 are going to be replaced with the item at index number 2, which is just 7. And finally 1, as you can imagine, is just going to be replaced with 4. So we can now get rid of this format string, having manually done those replacements. And now we see that we're comparing the first 6 characters encoded as hex into this. Well, if this is the hex version, then we fortunately have an easily accessible function to kind of decode that. Oh, okay, so we're just checking to see if the first 6 characters are kind of the mandatory format in front of the flag itself. Now, this isn't that helpful, since we probably could have already guessed that that was the case, but I'm going to go ahead and simplify this check. Great, so clearly what this does is checks to make sure that the flag starts with SDCTF, open curly brace. Great, next check. We see some interesting int and chars and conversions happening here. I don't quite understand it, so I'm going to go at the innermost level here, which is to say, like, this is probably the outermost level, and then int, and then inside of int we have this. So let's try and interpret what this is. What does Python see when it sees character 45? I don't really know, but the REPL will tell me quickly. Oh, it sees the character, I guess that's a hyphen, or a minus, depending on how you refer to it as. Whereas character 49, Python sees as a 1. Okay, so essentially what we're doing is we're passing it to the character, or I guess the string -1, which when you pass that into int, it parses it as an integer, which just gives you -1. So essentially what we're saying is, what's the last character? If you index into a string with a negative index, it wraps around and searches from the end of the string. Guess at index -1, which is the last character, does it match this character? And this character is, of course, the closing curly brace. So now we get an idea that these first 2 checks are just making sure your mandatory formatting is there. Which then leads us to the third check, which, by the way, we quickly, before we go into the third check, we take the parts in between the format curly braces that surround all of the different flags, and we encode that. This isn't as hex, but this is as bytes. So like as literal like numbers, an array of numbers from where each number is between 0 and 255, essentially. And that's what G is. So this last check is going to make sure that all that stuff in between the opening curly brace and the closing curly brace is correct. Looking here, we see that what it looks like it's doing is this is where we're actually using the big string that's inputted into this function, which, by the way, is just this big byte string down here. It's kind of garbled. I'm going to go ahead and assign it in my REPL so I can use it if I need to. Probably the biggest thing I notice is we're taking the guess contents and we're XORing it with numbers from the Fibonacci sequence over the entire string. And then we're comparing that to F. So in other words, the correct flag, when I XOR each number with its corresponding Fibonacci number, should look like this. But what's really nice about XOR is it has this mathematical property that if G XORed with the Fibonacci numbers is F, then F XORed with the Fibonacci numbers is G. It's a reversible operation easily. And so I can probably just take this line and pop it into here and just make a few changes. Namely, I'm iterating over F, and instead of the guess variable, I'm XORing F itself. And this spits out the byte string that G needs to be in order to satisfy that check, which is, of course, the stuff that needs to go in between our curly braces. So the full flag then is SDCTF, opening curly brace, very tasty spaghetti, as formatted, and then closing curly brace. And if I go back to the original prompt here, we see that that's indeed the case. And so we've correctly reverse engineered this file. So there you go. I've gone ahead and done the solution. Of course, yours is going to, your flag, that is going to look slightly different. So go through the process yourself, and I hope this was useful. Have a wonderful rest of your SDCTF, and I look forward to seeing the results. Bye, everybody.